Hey everybody, so this is going to be the second half of 7.4. So this is 7.4b, but before we get into it, I'd like to do a little exercise here. So what I want you to do is look at this expression and think about how you would expand it, multiply everything out, and combine like terms. Okay, so pause this and go through that and try to come up with a simplified version of this if you were to multiply everything out. All right, so hopefully the first thing you did was to take that x minus 6 squared, because it's an exponent, you had to do it first, and multiply that out, or just expand it out. And then use FOIL, right, to multiply x minus 6 times x minus 6, which should get you an x squared minus 12x plus 36. So then the second thing you'd have to do is distribute that 4. So multiply it times everything inside of that set of parentheses. And then finally, combine like terms. So basically just adding 144 and 3. So if you did it correctly, you should have gotten a simplified expression of 4x squared minus 48x plus 147. All right, so we're actually going to use that today for what we're doing, which is creating a quadratic function. Okay, so how can we've already determined how we can graph a quadratic function, but how do we write one if we just have some information? Okay, so the first thing we're going to talk about is vertex form. So we've gone over standard form. We know what that looks like. Vertex form of a function of a quadratic is this f of x equals a times x minus h squared plus k. So I know that's a lot of variables, but keep in mind that a, h, and k are just placeholders for numbers. Okay, so let's talk about what those numbers mean. So first thing is the h value is going to be the axis of symmetry, but it's the opposite of whatever that value is. That's why we have a minus. So just think of that minus there as an opposite. Okay, our vertex is going to be the opposite of h, and then whatever the k is. Okay, which might seem confusing until we see an example, and you'll see how easy that is. And then second is the a value. The a value just tells you what direction our parabola goes in, so whether it goes up or down. Okay, so whether it opens up like a bowl or if it's upside down and it points downwards. It also tells you the shape. Okay, so when we look at the a value, keep in mind that if it's a number bigger than 1, then the parabola is going to get much thinner, okay, skinnier, which is a stretch. Okay, we call it a stretch because of its relation to the x-axis. All right, so if this was our x-axis and it gets skinnier, that's called a stretch because it's pulling away from the x-axis. And then if it's a fraction, if it's a number smaller than 1, it's actually going to make it wider. Okay, it's going to be a lot wider. And this is called a compression because it's compressing towards the x-axis. Okay, if this was the x-axis. So just a couple things when we talk about our vertex form equation. So let's look at an example here. So we have f of x equals x minus 1 squared plus 2. So the first thing you should notice is what's the a value? Well, the a value is 1. Right? If we don't see anything here, we still have a number there. It's just a 1, which basically just tells you that it's not changed at all. Okay, it's just your normal parabola. Okay, it's not stretched, it's not compressed, it's not pointing downwards. Because it's a 1, we know that it points up, and it's just its normal shape. And then we can look at the h and the k value to figure out where the vertex is, which is nice because that's what vertex form is best for. It's for identifying where that vertex is. So if we look at these two values, since the h is -1, we're going to go with the opposite of -1. Okay, so that's why our vertex is at 1, because it's the opposite of -1. And then the k is 2, so that tells us the y value. So we know that our vertex is at 1, 2. If we graphed it, it would look like this. So here's our vertex here at 1, 2, and then it points up just like we thought it would. Okay? Let's see another one. So here, the a value is -2, which tells you a couple things. First of all, it tells you that it's going to point down because it's negative. We also know it's going to be thinner than normal because it's a number bigger than -1, or rather in this case smaller than -1, but it's not a -1, so it's going to be thinner than normal because it's stretched. And then we can look at the 4 and the -1. So if our h is 4, that means the vertex makes that an opposite of that, so -4. So our vertex is actually going to be at -4, -1. So if we graphed it, it would look like this. So notice we have our vertex at -4, -1. We know it points down because it's a -2 a value. And it's a little thinner than normal because it's a 2 and not a 1. And then my last example here, we see that the a is 1/2. So it's positive, right? It's positive, so it points upwards. But it's smaller than 1 because it's a fraction. So that means it's going to be wider than normal. And then you can look at the two values for h and k and determine that your vertex is at opposite of that. So -1, -2. Now remember, this opposite only applies to the h value. So it's the opposite of 1 and then -2. If we graph that, it's going to look similar to this, where we've got our vertex here at -1, -2. It goes up, right, because the a value is positive, and it's a little wider than normal because it's a 1/2. Okay, so that's kind of how our vertex form translates into a graph. So let's talk about, okay, well, how do we take something in vertex form and turn it into standard form? And that's going to go back to what we just did on that do now. So here's your steps for doing so. We're going to expand it, and we're going to FOIL it. Then we're going to multiply by distribution. And then we're going to combine like terms. And after we do all that, it's going to be in standard form. So let's look at that do now expression. Okay, this is the one we started with. And let's just turn it into a function by sticking an f of x in front of it. Okay, so now it's a function. And it's in vertex form, right? So if we were to do the same steps we did in the do now, we would expand it out, combine like terms, expand it out and combine like terms to get f of x equals 4 times, we're going to expand this out and FOIL it, so x minus 6 times x minus 6 is going to be x squared, let's see, minus 12x plus 36. And then we're going to distribute the 4. Okay, so that 4 goes to everything inside of there, which is going to give us an f of x of 4x squared minus 48x plus 144 plus 3. So then our last, so that was first, second steps. The third step is combine like terms, which is really just the constants. So our standard form of that same equation or same function is going to be 4x squared minus 48x plus 147. So now we have it in standard form. All right, so how can we use that to create a function no matter how we're given the information, right? We could be given a table, we could be given a situation where maybe we have to draw a picture or maybe they give us a picture, or just a plain old graph, right? If we had a graph, we should be able to do the same thing. So let's look through this. If we have a table, right, and we're told it is a quadratic, the first thing you should be looking for in any of these is a vertex, okay? And we know the vertex is that center point, so wherever you see this mirrored values, then the one in the middle is my vertex. So what I'm going to do, and I'm just going to use a simpler version of I'm not going to use f of x just to keep things simple. So y equals a times x minus h squared plus k. So keep in mind that this vertex here is our h and k, but remember that the x value, or the h, is the opposite. All right, so we're going to plug this in. We're going to leave the a there because we don't know what that is yet. And we're going to do the opposite of -3. So we're actually going to put +3, right? Because that would make the opposite of that a -3. And then my y value is 0, so it's just +0. You don't need to write it, but I'm going to just for reference here. All right, so then the second thing you're going to do is pick one of your other points. It doesn't matter which one you choose. Could be any of these. I'm going to pick the easiest one, which is anything that includes a 0. It doesn't have to be this one. I like the ones with zeros because they're easier to figure out. So keep in mind that these are x and y values, right? So I'm going to substitute a 9 here for y, and I'm going to substitute the 0 for the x. Now watch what happens. That's going to give me a 9 equals a times 0 plus 3 squared, and I'm not even going to write the plus 0 because it doesn't matter. So now I'm able to actually solve for a, which is the whole point of this exercise here. So 0 plus 3 is 3. 3 squared is 9. So what I actually have is a times 9. And in order to get a by itself, I'm just going to divide both of these by 9, which actually works out nice because now I know my a is 1. So now you have all the information you need to write the function in its completeness, right? We know the a value is 1, so this is just a 1. And we know we had an x plus 3 squared plus 0, which has a lot of extra information we don't need. So I'm just going to simplify it down to x plus 3 squared. Okay? So this would be vertex form. Now, if I asked you to do it in standard form, you'd go through this whole process and then just expand the x plus 3 squared. So that would give me, let's see, x squared plus 6x plus 9. So this would be the standard form of the same function. So these are both the function from the table, but one is in vertex form and one is in standard form. Okay, so it really depends on what I'm asking you to do. So that's how we do it from a table. Let's do it from a situation. So let's say, obviously, this is some situation where probably something got thrown off of a cliff or a building, or it could be anything. But what we're looking at is this 25. Okay, so we know it started out at 25 feet. And we don't know where this is, but it doesn't really matter because we're just trying to write the function. So we just need another point, which is why we require a second point. So we're going to start with this vertex, okay, 0, 25, and we're going to fill it into our a times x minus h, but now our x minus h, the opposite of 0 is just 0. There's no opposite, so we're just going to use 0. And then the y value is 25. So that's my k. This is the h and this is the k. So this is 25. Okay. Then we're going to set the other point, 1, 9. We're going to replace the y with a 9. And we're going to replace the x with the 1. Okay? And we're going to use that to figure out whatever a is. We need to know what a is. So we're just going to simplify this down. So a times 1 squared plus 25. So to get a by itself, obviously 1 squared is 1. And if I subtract 25 from both sides, I'm trying to get a by itself, right? We're going to end up with a -16 for an a. Now this -16 is actually going to be, you're going to see it a lot, okay? Because we're dealing with feet in seconds, so feet per second. So gravity always works on a constant here on Earth. So it's going to be 32 feet per second, and there's a whole way to calculate, what this is going to be. But we always end up taking half of that value. So you're going to see this negative 16 a lot when you're dealing in feet per second on Earth. Okay, so we have enough information. We have our A value, we have our H value, and we have our K value. I should probably use a highlighter here. So we have our A, we have our H, and we have our K. So we have all the information we need to write the function. We just replace the A with negative 16. We don't have to write x minus 0, but it's not going to be wrong if you don't. But you could just put an x squared here if you wanted to. But I'm just going to write it as x minus 0 squared plus the k value of 25. Okay, notice that the constant is the same as the y-intercept, and that's pretty normal, right? So this would be my, if I simplified it, negative 16x squared plus 25. This is my equation in vertex form right here. This is vertex form. And this one down here is already expanded for us because there wasn't another term in there to multiply. So this is my standard form here. All right, and then the third example, if I just gave you a graph, once again, you just need 2 points. Most important being, I must have the vertex, the highest point on this case. So that's a 1, 1. So I'm going to start there. I'm going to leave an A. I'm going to do the opposite of the H, right? Opposite of 1 is negative 1. And then plus 1 is my K, so plus 1. And we're going to use the second point to figure out the A value. So we're going to use a negative 3 for the Y, right? Because this is our Y value. And we're going to use 3 for the X value. So 3 minus 1 squared plus 1. So now we have everything we need to solve for A. So I'm going to go ahead and simplify this a little bit. Negative 3 equals A. 3 minus 1 is 2 squared plus 1. And then order of operations, we're just going to do 2 squared is 4. So 4A plus 1. Okay, we're just solving for A. So subtract 1 from both sides, which is going to give me a negative 4 equals 4A, which you can probably do in your head. That means A is negative 1. Okay, so now we have all the information we need. We're just going to write this in vertex form. So y equals negative 1 times x minus 1. Remember, we're using this here that we started with, squared plus 1. So this is the vertex form. So if that's what I was asking you to do, you'd be done at this point. But if I told you to put it in standard form, you're going to start by expanding the x minus 1 squared. So negative 1 times x squared minus 2x plus 1 and plus 1. Then you're going to distribute the negative 1. So negative x squared plus 2x minus 1 plus 1. And then finally combining those two constants at the end because they're like terms. So negative x squared plus 2x. So this is the standard form of this function. And this one up here is my vertex form of the function. Okay, so you might need to run through those examples a couple more times. The assignment's going to be based off of this idea of creating a function. So see you guys in class.